the pointers from where you can refer. Like last time we have released summary session like from week 1 to 12. So that thing we can release.
So when can we expect that?
Today only.
Okay, thank you.
Yeah, but it will not be similar to the what we have released for page 1 and page 2.
Okay.
Yeah. So we'll wait for a couple of minutes and we'll start. Okay. Yes, Viraj, you want to ask something?
Yes, sir. Good morning.
Good morning.
Sir, will there be any mock paper for this interim exam?
No. Mock
Okay,
is they are just too familiar with the what type of question will come, right? For quiz and quiz 2, I think you already know which type of question will become. So yeah, there will be no mock for that. Yeah.
How many questions can we expect in the interim exam? Number of questions.
Number of question will be around 25 to 26.
Okay, sir. Thank you.
Yes, Shreya.
Yes, sir. Good morning. I had a few doubts in week 9 and 10. So I can ask during the session only?
Yeah. And during the session, you can ask, right?
Okay.
Yeah.
Yeah, thanks.
Sir, when can we expect the results of OPP?
OP, I think this week only you can expect.
This
I'm
week?
not sure about that. Yeah.
Okay.
But yeah. Okay, so hello, good morning, everyone. So yeah, so at first we'll take your question and then we'll solve few numericals based on the previous interim question paper. Okay. So anyone have any doubt from week 1 to 4 first? Yes, any question? Any doubt in week 1 to 4? I'm audible, right?
Yes,
Yes, sir.
Okay, thanks. Yeah. Okay, any doubt from week 1 to 8?
Out from this, what is the difference between procedure and function?
In SQL, right? Hello.
Yes.
Am I audible?
Hello.
Yes, sir. He's saying in SQL. His voice is breaking actually.
Yes, Ras, right?
Yeah.
Yeah, so generally functions we define for whenever we want to use trigger or during the transaction handling, we can use that. Procedure is basically in the exists in the transaction handling only, but functions we can define for during the triggers also. Like just you define the function in Python. Similarly, we can do that. Like you simply define the function like for a plus b, and then you put inside the function that attribute. Same thing it is there in SQL only. You can go through the slide. There is few example also. Yeah.
Sir, I would like to add something.
Yes.
In function, function is returning some value based upon the expression, right? Whatever you want to suppose, if you want to return the sum of number, right, 1 to 5. So it's kind of return means you using the loop and the return some value, right? Who is that? Prash, is it clear? So return something in the function it is.
Yes, sir. Sir, during the when we write the procedure, we actually specify the variable in which we will be getting the output value.
Yeah. Input value and output value we are taking in the function procedure.
Yes, sir. So is that optional in the procedure? The output value, the variable we write for the output to take output, is that optional?
No. That is the main difference between function and the procedure. Hello.
Yes, sir.
Is it clear? And the in the function are we can execute using the select and the function name. Suppose your fun1 is the your function, so you can directly execute using the select fun1 and the function, right? Am I audible?
Yes, you are.
Yeah. And but you cannot execute using procedure cannot using the select.
Yes, sir. We can only use
yeah. And inside the procedure you can execute a function, but vice versa is not possible. Inside the function you cannot execute another procedure, right?
okay, sir.
Okay. These are the difference, and many more you can check it out. Okay. Thank you, Piyush.
Sir, I had one small doubt. In an array, the order of insert and delete is n, right?
Yes, means complexity. No, am I audible?
Yeah. The complexity, time complexity.
In certain deletions order of n. Yeah.
Order of n, right? Okay. Thanks.
Okay.
Excuse me, sir.
Yes.
This session will not be live.
Your voice is.
Saurabh, you are not audible. This session is live.
Am I audible?
Yes.
This session is being live streamed on YouTube or not?
Yes, it is live stream on YouTube. Yeah.
Okay.
YouTube.
Thank you.
Hi, this is Srinivasan. I had a question. I kept getting confused about what's an extraneous attribute. Can I ask that question?
Yeah.
Hello. Yes.
Yeah. There was this question in the quiz also, right? If I remember. Okay. Like M to K, K to J, right? And then L M to K. right? Something similar. So in this, original was M2K. So now we just said L is extraneous attribute. But why can't M be the extraneous attribute? What if there is a dependency from M2K? So that is the question I asked also. I didn't get the I couldn't get the explanation. We discussed in the discourse also, but I still couldn't figure out.
Okay.
Why did we see only M is extraneous and not L? Why is not L extraneous?
Okay, we can take one question based on that. Okay.
Okay, thank you.
So is this visible, my screen?
Yes, sir.
Yes, sir, we can
Yes,
see it.
sir.
So this question is taken from the last term. So the question was different, but here we can check the extraneous attribute is there or not, the functional dependency. Okay. Okay. So here, okay, don't go through this. Okay. Here you can consider the relation R having this attribute, and this is a functional dependency set where A determine B, and these are the functional dependencies. Now we have to check whether in this ABCD is any extraneous attribute is there or not. In this EF, E is extraneous or not, or F is extraneous or not. Because whenever there is on left hand side there is more than one attribute, you have to check whether there is any extraneous attribute or not. So first let us check for this. Is there any extraneous attribute here? How to check that? Yes, anyone?
We need to see if we remove that attribute from the dependency. The resultant dependency can be derived from the remaining dependencies, like ACD to E. Can it be derived from the rest of the dependencies?
Yeah, so that is one of the thing. Again, one more thing, like if we take the closure of A, C, or D, and if there is if it includes B, then we can say that B is extraneous attribute also, right? Like here, if we take the closure of A, in the closure of A, there is B, right? If we take the closure of A, so there is AB, right? So here we can clearly say that B is an extraneous attribute.
Yes, sir, I understand. So this is here it is. You see. Now let me ask, how do we know A is not extraneous here?
A is not extraneous, right? So now let us take the closure of BCD. Can we get A from that? Or if we skip this A from BCD, can we determine E? No, right? So A is not an extraneous attribute. In the slide, there is one algorithm for that. Let me check the slide. Srinivasan, any particular doubt in this, like how to determine?
If you take the quiz 2 question, right, that's a much simpler question. Right? Only
Okay.
3 dependencies, and one had 2 on the left side.
Okay.
Piyush sir, can I take this question?
Yes.
Quiz question. Okay.
Oh, yeah. This question, right? Whoever asked this question.
Yes. Yeah.
Okay. Okay.
So
So
my main doubt is, suppose M could have K could have a dependency on M, right? That M could determine K. That is possible in a relation, right? Or is it not possible?
so yeah. So okay. Can you say what you want to say?
See, suppose I have a relation
Yeah.
where L determines J,
L determine J,
J determines K,
J determine K,
and M also determines K.
M also determine K.
Yes. So is this possible?
So it's yeah. It's so means from this relation, right?
So this is the question of canonical cover. So first we need to find out the extraneous attribute. Then we need to remove the redundant functional dependency. Then we'll get the canonical cover of this. given functional dependency. So if
Yes,
you
I understand. So here, obviously, that it is seen as in L to M, LM determined to K. M is
yeah.
seen as extraneous. But I just trying to maybe it's a question of understanding. Why can't L be extraneous here? How do I know that L is not extraneous at all?
Okay. Okay, got it, your question. So you want to say why L is not extraneous attribute, right? Hello?
That's right. Yes, yes.
Okay, see functional dependency are L determine J determine K, then LM determine K. Okay, so take M closure with the help of this functional dependency. So what we'll get? Only M closure, only.
Yes.
What will get? Only M closure,
It will
Yes.
only be M.
only M. So we do not get K. So L is not extraneous attribute. So if you take L closure, so what will get? L determine J determine K. Then you get J, K. You will get K. So M is extraneous attribute.
Okay, I understand.
Okay,
So
you
now,
got it.
yeah, I get it. I get it. Suppose
Yeah,
M
suppose.
does determine K in my
Okay.
schema.
Oh,
How do I
M
even write it?
suppose an extra functional dependency M determine K, right?
Okay.
Okay, then yeah, then maybe M determine K, then L is extraneous.
Yes. So this is so from the given question. So how do we? So I obviously got this question wrong because I was just trying to figure out.
Yeah. So you have to see.
Even option B also could be for me.
So,
Even option B seemed like correct.
Suppose AB determined X. So if A is extraneous or not, we have to check take B closure. If you get X, then A is extraneous attribute. B is extraneous attribute or not, take A closure. And if you get X, then B is extraneous attribute. You got it?
Okay, so that way I just apply the algorithm. But suppose M does determine K, I won't be able to express it this way. I have to figure out some other way of expressing it.
Yeah.
Okay, so that way, if we are given a question, we just follow the algorithm. Don't try to put any other logic. Okay.
Yes.
So because in this thing, I thought D is right, but I also felt B also could be right, and finally I chose B. I mean, like when I revising the paper, I chose B. Okay, thank you.
Okay.
Hello, sir.
Yeah.
Sir, can I ask a question?
Yeah.
Sir, suppose AB determines C together. AB together determines C. Can I say A determines C and B determines C?
No.
Okay. No, you don't say.
On left hand side, decomposition rule is not applicable. Like AB determines C, then A determines C and B determines C, right? No. You cannot say that.
Okay.
If A determines B, C, then we can say A determines B and A determines C.
Yes, so left hand side I can decompose, right?
No.
Okay. Thank you.
Yes, I was audible. In the previous question, like if there is M determined K is there in the original functional dependency, then LM determined K is redundant functional dependency. So we can remove that functional dependency, and then the second option will be correct. I was not audible, I think.
No, I could hear you. Sorry. Okay, I understand.
Okay.
But I think if you have a question, I think we should just apply the attributes. I mean, apply the algorithm, not worry about the original part.
Okay. Okay, yes, anyone? Any other question?
Sir, in the same question.
Yes.
In the last step where we are removing the redundant dependencies. So by definition in the slide, we are only worried about the LHS should not be the same on multiple dependencies. That is what we are implying by removing redundant dependencies?
No.
But the slide says ki we are not see in the lecture it was applied ki we use various types of transitive dependency and minimize and go. But in the slide it says ki you only ensure ki the LHS is different karke. Are you getting my point, sir?
Yeah. So can you tell the slide number?
So if it is a minimal cover, then we can say that, right? Like in some textbook, like they do this, like it is a minimal cover. That is the only difference between minimal cover and canonical cover. Right, Pradeep?
I'm just checking the slides.
Yes. Sir. Well, Srinivas, you can watch the tutorial also based on this canonical cover. So in that, ma'am has said that, okay, so A determines B and B determines C. So if we say A determines C, then that is a minimal cover, right? In some textbook, they use that. Like same you want to discuss, right? In option 4.
Yes, sir. That is what, because again the confusion from discourse forum is, suppose if there is we can do a transitive dependency and lower it further, but still we are saying this is a canonical cover. That is my question. For option 4, you can do a transitive dependency and lower it further, but still you are claiming that it is because we can derive all the main attribute, main functional dependents from this. So we are still calling it a functional, canonical cover.
That is basically minimal cover, but we are following the Koth reference book. So they consider both minimal and canonical cover as the same. In different textbook, they have different terminologies.
Okay.
Yeah. In the tutorial also we have mentioned this. Ma'am has mentioned that. Okay. Yes. Any other question from week 1 to 8?
Sir, slide 24.11, sir.
Okay.
It says ki only the left hand side should be unique. Correct?
Hello. Hello.
Yes, Pradeep.
Yeah. What does that mean? I will tell you. So, is it visible, right? Yeah. Hello.
Yes, sir. Yes, Pradeep.
Yeah. So, after calculating the canonical cover, suppose you get this one, right? So this is the minimal cover, canonical cover. So what says the left side should be unique. So you can see A is there. So you write it down as the PC. That is the point. So, but these two are same. Is it clear, Srinivas?
Yes, sir. Now it is clear.
Okay. Thank you.
Okay. Yes, anyone from any doubt in week 1 to 12?
Sir, I had a few doubts in week 9 and 10. So in week 9, suppose we are asked to find the size of a sparse index, then we need to use the block size to calculate it, right? Like like one of the practice questions, we have been given the size of the key and the pointer, and we've been given the number of records and the number of records per block. So we have to multiply the key and the pointer size with the number of blocks, right? Because it's asking for sparse index.
Okay, Shreya, am I audible, right?
Yes, sir. Yeah.
So, yeah. So let's share my screen.
Yeah.
So in the question, suppose the sparse primary sparse indexing. So what is your doubt specific?
So my doubt is, I can just tell you the numbers from that example only. There are 100,000 records.
Numbers of records is 100,000.
Yeah. There are 10 records per block.
10 records per block. That is also called the blocking factor. Also, we can call the.
Okay.
Means in one block, how many record can come?
Right.
So yeah, that is
10.
Okay.
Size of the file is 100 MB.
Size of the file means the data file is.
Yes.
100 MB.
Yeah.
Yeah.
Then size of the key is 30 bytes, I think.
Means search key. SK means search key, right? So let me write.
It just says key field is 30 bytes.
Yeah, that means search key field in the index.
Correct.
Index file.
Right.
Search key is your
30 bytes and pointer is 10 bytes.
Pointer is pointer size, right?
Yeah.
That is 10 bytes.
And we need to find how many blocks are required to store the index.
Store index file, right?
Yeah.
So here you have given the block factor.
Correct.
So you can suppose first we in data file you have to find how many blocks are required.
Correct.
So this is the total numbers of block, and in one block 10 record can accommodate. So the numbers of
10,000 blocks. Yeah.
Yeah.
So my doubt here was 10,000, right? I think.
Yeah.
Okay. My doubt here was when we are trying to find the total size of the index, we need to do 30 plus 10 into 10,000, right? Because it is sparse indexing.
No, you have to find this is the index file. Suppose there is the index file, right?
Yeah.
This is your index file.
Yeah.
And this is your search key.
Yeah.
And this is the block pointer, right?
Yeah.
So one record's total size is 30 plus 10.
Correct.
That is 40.
Yeah.
And the Spark index, how many record possible? So this is the numbers of block.
Correct.
Numbers of blocks equal to numbers of entries in the index file, right?
Correct. Correct.
So total index file size is this one 40 into
10,000, right?
10,000.
Yeah.
This is the numbers of byte.
Okay. Okay. So that was just my confusion because the solution takes 40 into number of records.
Yeah.
It's calculating
And
for dense index, right? If you take number of records.
yeah.
Okay.
The sparse index, you have to remember, so the numbers of block in the data file equal to numbers of entries in the index file.
Okay. Okay. So, okay, fine. That was just one doubt. The second one is from week 10. Suppose we are given a schedule, which is already a serial schedule, and we are asked how many schedules can this be serialized into? The schedule which is given, do we include that or do we exclude that?
We are excluding that.
Okay, because again, the graded assignment question includes that.
Yeah,
also.
one question is there.
Yeah, okay. So we have to exclude it, right?
Yeah, suppose question is given like that, how many numbers of view equivalent is possible, then you include it. So yeah.
I think the practice question was asking how many view equivalents are possible, right? That also excludes the given schedule.
Yeah. So if we are using that convention, then you need to exclude that, right? So
okay, so whenever we are asking equivalent to or serialized into, then we exclude what is already given.
Yeah.
Okay. Okay, so that was the second doubt. And the third one is in week 12, there was a table on the access time and seek time from the index and all of that. Do we need to remember all those formulae? I'll just tell you which lecture.
Okay, which?
I think the first lecture itself.
Okay, let me see.
56.15. The file and yeah.
56.15. Okay, let me see. No, don't you have to remember.
We don't need this formula, right?
No.
Okay, fine. And one last question on graded week 12. Graded week 12, the second question, I couldn't understand why option 3 is correct.
Yeah, which? Can you
graded assignment 12, week, the second question.
Let me see.
Okay.
Hello. Yes, Shreya, in graded assignment 12, question number 2.
Yeah.
So what is your problem in this
The
question?
third option is given as correct. I couldn't understand how third option is correct.
Okay, let me check.
It is based on equivalence rule, right?
But is the attribute L is present in both the relations? How do we know that? It could be that it's there only in one, right? Or okay, then union is not possible.
Yeah, if
Okay.
it is not present, then union is not possible.
Okay.
Yeah, if you see the second option, theta is the condition, right?
Correct.
So theta belongs to both 1 and 2, E1 and E2. If theta 1 is there, then the theta 1 is belong to E1. So then we can say that second option is correct. Theta is given, so it means that theta include the attributes from both the set, like relation E1 and E2.
Okay, so is it necessarily that it has to be from both, or it can be that it can be from either?
Theta.
Yeah.
It can be either also.
Okay.
But whenever the like we have not specified that it includes from both the relation.
Okay. Okay. Understood. Yeah. Fine. Fine.
But
Those
in
were
the
my.
question will specify that. Don't worry. That theta one is belong to E1.
Okay. 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 Understood. Yeah. Thank you. Thanks everyone for clarifying all these.
Hello, sir. Am I audible?
Yeah, Abhishek, you are.
Sir, for this question only. So, sir, why the second option is not true?
Yeah, it is not given that the theta is belong to which one. So it may be possible. The second one is also possible.
Okay, so I mean, let's say if this in this option there were two possibilities were given. Like this is one of the possibility, and the other possibility is like selection of theta based on E2 union E1.
Yeah, that is partially correct. The second statement is.
Then both of them will, I mean, make sense, right? Both of them together will make sense then.
Yeah.
Okay. And another thing, sir, I am having problem in understanding logical undo and logical redo, that part. I mean 11.4. Could you please give a brief explanation?
Logical undo. Yeah, let me check.
It means the same thing like undo and redo. Like if a transaction is failed, then we need to undo those, right? If it is immediate modification scheme.
Yes, sir. I mean, in case of physical undo, we were changing the variable, changing the value of the variable to the previous value using log table, right, sir? In case of physical undo. In case of logical undo, we are just deleting it.
Yes. Yes, Abhishek. You have to just in B plus T concurrence algorithm, just suppose you are means suppose okay, let me share my screen.
If I can explain, mention one particular thing, Srinivasan here. See, you do logical undo because the physical undo was not possible. So that way, changing the value that was done in the physical operation is not possible because something else has happened. So that record itself may be somewhere else and all the stuff, or many other things could have happened. So the whole logical comes only because the physical undo is not possible. So the logical undo will always be very different from what you do in a physical undo. So the physical undo was an update, you will reverse the update. The physical was actually, or the initial operation was a deletion. You will actually insert it back.
So in case of logical undo, are we changing anything in the, I mean, at physical level, or we are just doing it logically? We are just implementing it logically.
Okay, everything happens with the database, but it's physical undo. Okay, the way I understood physical undo is you exactly whatever you did, reverse it. Right? Okay. Whereas in a logical, you do an operation that logically undoes the original operation. So you don't reverse it exactly, but logically it undoes it. So maybe the instructor can explain it better.
Yes. See whatever Srinivas tells, it's very good way. So let me share my screen. So yeah. So which part?
Sir, the whole logical undo itself, sir, logical undo, the concept behind logical undo, the whole thing. a bit is cleared by Srinivas, but
Yeah.
yes, sir.
Okay. So,
Actually, I am having problem with this lecture video. This is 11.4. No, sir.
yeah. 11.4.
Yeah, sir, having problem.
Okay. So, yes. Okay. Let me. Okay. Example.
Yes, sir. If you could explain this example, that would be.
Yeah. Okay. So okay. Okay. See. Suppose my screen is visible.
Yes, sir. Yes, sir.
Okay. So suppose T1 T0 status T0B 2000 to 2050. Then T01 operation begin. T0C 700 to 600. Then
Sir, I am interrupting, sir. Sir,
yeah.
operation begin means it is doing some kind of arithmetic operation. Is that is that the operation begins referring to?
Yeah. Suppose C means suppose you want to update the value something. Suppose this 700 to 600, right?
Yes, sir. Yes, sir.
So then there is a logical undo operation, and suppose some kind of failure or crashes occur, then plus 100. So what about the suppose 600? So if you plus 100, then you will get whole value. So
yes, sir.
So plus 100. So this is a logical undo.
Sir, can you please explain that again, sir?
Okay. See, T01 oppressor begin, then T0C, it's changing the value of 700 to 600. Then corresponding to, there is a logical undo means log records. Suppose failure occurred, then operation in C, if suppose there is changing 600, this is a means old value, this is a new value. So if we add 100, then we will get old value, right?
Yes, sir. Yes.
So this is a logical undo.
Yeah, Abhishek, if in the case of log, if that C plus 100 that is not given, so then we can say that is a physical undo. We have to perform. Like logical undo, it will maintain the separate log for that. There you can see operation end C plus 100, also operation end C plus 200.
Okay, so we are keeping like whatever value we are changing to, we are keeping that as a record. Like if the value of C is some failure occurs, and if the value of C is not changed to the desired value, for let's say for the first case is 700, it is we are not able to change it. Then with the help of this log, that is log in operation end C plus 100, we can get back to the desired value, that is 700.
700, yeah.
Yes.
So that is logical undo. If that log is not there, but still we need to undo that operation, so that is physical undo, right? If the transaction C fails.
Yes. Okay. Okay, sir. Sir, let's say, when we are committing not committing, when we are putting the value inside the variable C, that is from 700 to 600, that is basically we are subtracting 100 from it. So why putting this value from 700 to 600 if we have some issue and we have I mean, there is a failure, and we end up, and the transaction does not happen. Okay, so we are getting the 700, getting the value of C as 700 only. So now, if we do the logical undo operation, then we will end up getting 800. So can that be a case?
See, this is a means suppose any failure occurs or suppose and you have to roll back, then with the help of this rollback we can undo the we can get old value. So suppose some failure occurs, then with the help of this log records we can get old value.
So basically you're talking about that like 700 will get updated to 800 like that.
Yes, I mean, I am trying to update the value from 700 to 600, but due to some failure, system failure, I am not able to do that. So now I am stuck with 700 only. That is the initial stage only. Okay, but but somehow I am able to log this logical. Somehow able to take. Log this operation end C plus 100. This value, this log. I am able to input, take that input. Then if I do the logical undo, then I will get 800. I mean, can I explain myself, sir?
No, because your failure is happening before that operation, right?
Yes, yes.
Then how will that log will get executed?
Okay,
that
so
not
that.
happen, na?
Okay.
It
So
is step 1, 2, 3, 4, 5, right? So failure has occurred before step 5, so that will log will not be there, right?
Yes, sir. Okay. Now I understand. Yes.
Also, there are two different schemes like immediate modification and deferred modification. In the case of immediate modification, you have to undo the operation, right? But in the deferred case, because we are not updating the value in the data in the buffer before the commit, so we don't need to do anything, right? We can simply ignore that operation. We can restart that.
For undo, yes, sir. Like we can ignore whatever we have done and restart from the initial state.
Yeah, that is in the case of deferred modification scheme, because that value is not updated in the buffer.
I mean, if I am correct, like we are not committing it into the.
Yeah, we are not committing it right now.
Yeah. Okay. Yes.
And I think there is a rule of if that operation won't end, so we won't perform the logical undo, then we will perform the physical undo. So that's where he is confusing, I think.
Yeah, here you can see my screen is visible, right?
Yes, sir.
So here we have mentioned deferred database modification scheme, and the crash has occurred just after step 7. Means T0 is committed, right?
Yes, sir.
So we need to redo the T0 operation transaction, but T1 transaction is not committed here. So we need to no action is taken and simply the transaction is restarted. But if here it is immediate modification scheme, then in that case we have to perform the undo operation.
Okay.
Because in the default, what will happen? The value of D will not get updated. It is there in the buffer only. Like only after transaction T1 commit, then you will get update 30 and 50.
Yeah. Oh, yes, sir. Yes, sir.
That is.
Thank you,
So can you once explain the direction of redo? Like in undo, we like move from backwards to forward, to backwards to like from right hand side to left hand side. But what is the case of redo? Like how we decide that?
Opposite case, like if the transaction is committed, we need to make the changes in the DIX, right? So 200 to 50, since the transaction is committed.
So it will what it will search for? It will search for the start of the transaction, or it will search for the commit statement.
No, if the transaction is committed, then it will perform the redo operation.
Okay.
So just a doubt there. So all transactions we first do a redo and then do an undo, right? Because that's like the redo will classify which ones need to be undone and which ones are not, and then we undo. Is that correct?
Yeah, that is correct.
Okay. Thanks. Just one more quick doubt. I mean, maybe if it's not relevant, we can skip it also. In B plus trees, early lock release is needed only for concurrency control, or for updating every value it is needed. Like suppose there are three items A, B, C.
Yeah.
Early lock release is needed to update every item, right? Like, because suppose we have a serial order execution only, and this is T1 which is updating A, B, C. Now, when A is being updated, there is a node lock. But without, suppose B also is along the same path, then B can't be updated, right? Because A is holding the lock on that path.
Yes, yes.
Okay, okay, thanks.
Like similarly, I have also doubt over there. Like in the slides, it was mentioned when we are performing the insert operation in B plus tree. So we are inserting V1 and R1, something sort of this, and then we perform the another operation, another transaction on the same node. Sir, can you explain that part also, like diagrammatically, if you can explain? Like I'm not getting why we have to perform the delete operation. Why can't we undo that thing?
Okay, so let me share my screen.
Yeah.
So this part, right? Hello.
Yes.
Hello. Yeah. So if so, a value in a B plus tree is updated by one transaction T1 which insert an entry. So suppose suppose so, by another transaction T2 which insert an entry V2 R2 in the same node. So so which part you did not understand this?
So can you explain this part diagrammatically, like what we are trying to doing like earlier we are inserting V1 R1 at the same node, then we are inserting V2 R2 again in the same node, and then it says that at this point we cannot undo transaction T1 by replacing the content of the node. So we have to perform the delete operation. Like how is this happening?
So see, suppose you are on suppose you want to insert in B plus tree. So in means splitting will be made possible, right? Hello.
Yes. Splitting
so,
may possible.
Yeah. So when splitting occurs, so in that time means so yeah, so can you post in the Discord so we'll discuss in details. So actually these are the advanced concept. So
yeah, actually I was very confused, like why we can't perform undo and how the same insertion is happening in the same node 2 times. So okay, I'll post.
yeah, so I'll give a brief explanation about this.
Okay.
Okay.
Sir, hello, sir.
Yes.
Sir,
Hello?
I cannot understand why in RAID 3 we cannot service multiple requests simultaneously.
Hello. Okay. What is your question?
Sir, why we can't, I mean, in RAID 3, why we can't service multiple requests simultaneously?
Can you mention which slide it is present?
Yes, sir. It is slide number 55 and page number 14. That is 55.14. It's 11.5, sir. Lecture number.
Yeah, 11 point and 55.14,
14, sir.
14. Is it visible, right?
Yes, sir. Yes.
Yeah. So RAID 3 has the single check parity bit. Yeah, up to this is clear. Yeah, this is the parity bit.
So yes, sir. I mean that is single check with parity information. That means A1, A2, A3. I will do a parity bit on these three, and
Yeah.
A4 to A6. I will do another parity bit on the other three. Right.
Which one? Second. What is your second point? That is.
So, sir, single check disk like so we are computing a parity bit for I mean depending on the three disks.
This three. Yeah, three disk.
Three disks. Okay,
Yeah.
sir. Okay. So if we want to retrieve the data, let's say
Yeah.
I want to so I have a bytes. This is byte stripping. So I have a block of data. So now I am dividing it into 6 bytes.
Yeah.
So if I want to retrieve that byte, I have to retrieve all these 8. I have to retrieve the information from all these all these 4 disks, right? In 2 levels.
In the 2 levels. Yeah.
That is the yellow portion. I have to
Yeah.
retrieve that yellow portion. So what does it mean that service multiple requests simultaneously? I mean, is it what does it mean, sir? I cannot understand what it is trying to say. I mean, multiple requests simultaneously.
So that is the yellow. So this is so because the any block of data can be spread across this setup and reside the same physical location on each disk, and thus a single input output request to be addressed by working on every disk. Okay, the point is in one block is divided into the byte. Yeah. Hello.
Sir, could you please repeat that again, sir?
Yeah, suppose this is a block of one block of data, right?
Yes, sir.
And you divide it into byte.
6 bytes.
So yeah, this is the byte level.
Yes, sir.
Yeah, right. And you place this first byte in here, the second byte is here, and the third byte is here, and fourth one is here, right?
Yes, sir. Yes.
So whenever you do any input output operation means you want to read and write.
Yes, sir.
Yeah. So you need to access every this disk, this one, what you have just said.
Yes, sir. The whole yellow block. Yes, sir. We have to
Yeah.
access the whole yellow block. Yes, sir.
So yeah, that's why it cannot means multiple service means in the simultaneously you cannot do the read write.
Oh, so when we have to read it, and when we have to write it. We cannot do that simultaneously.
Simultaneously, yeah, that is.
Can we do that for other RAID type, like
Yeah.
like let's previous one? So how is that possible? If you could
Yeah, previous one you can see here.
sir, the RAID 1, if you can explain for that RAID 1.
Yeah, in RAID 1 when you perform the write operation, so you have to perform in both the disk, right?
Yes.
But during the read operation, you can read either from this one or either from this one. So you can read simultaneously, right?
Okay. So if in case of RAID 2, we cannot do that, right? Yes, sir. This one.
Yeah. We cannot do that.
So whenever we are using parity, we cannot do that.
No, that is not for parity. That for we are stripping that things.
Yes.
So,
That is not for parity. Yes, I mean in the second case, we are storing a duplicate kind of thing. So we are writing it reading from one, and we are writing into the another disk. That's how we can do simultaneously read and write. But in this case, or in RAID 2 and RAID 3 or RAID 4, we cannot do that. Am I correct?
yeah. Because we need to access for the read operation. We need to access the several disk, right? This one, this. Yeah, this one. Right. That's why.
So if we want to write, we have to access all these disks, and if we want to read, we have to access all these disks.
Yeah.
So basically, simultaneously, we can do that for only RAID 1.
One, yeah.
Okay.
So transfer rate will still be higher when we do it from a single block only, right? Like from when there is striping, even the transfer rate is slower, no?
Transfer rate is here is fast, right? Okay.
That's where I was a little confused. So transfer rate, even somewhere I think it was mentioned, even though it is from multiple disks, it is slower than a single disk. 1 minute.
Sir, I think because the seek time, it might get slower, no, sir? Because for each disk,
time will be similar, right? Like it will be similar for all, no?
Yes, I mean, but we have to do the seek for each and every disk, no? It is not that where we are storing A1, in that exact same location, in the another disk we will be storing A2. Is that how we store, sir?
No. That is not possible. So suppose you put this data in the first location, this may be possible in the second location. Yeah.
Yes.
Yeah, you're right. I think in 55.8 it is mentioned that seek or access time is worse than the single disk. You're right. Yeah. In the next one, sir. Yeah, the first part it mentions that.
Yeah, that is.
Okay, so like, can we say then that byte level striping has a faster transfer rate, or that also is this?
I think that also the same things is applied to it.
Okay. Okay. So generally block level striping is what is preferred.
Yeah.
Okay. Okay. Thanks.
Can you explain briefly the concept of parity? Because I have seen your previous video, previous lecture on that. So I was not confident about the parity. Can you explain it again briefly?
Okay. So parity is the extra bit we are using for the, if there is any error is occur, so we can get the original data. So it is used for the detection, and somewhere it is also used for the recovery, you can say. Means what is the original data we can. Yeah, is it visible to you? Right?
Yes, sir. Screen is visible.
Yeah. So I just take a dummy example. So this is the disk 1. This is disk 2. Disk 3. And this is the disk 4, which we store the parity bit, right? This is used for the parity bit. So suppose the data is 101, 11, and 110, suppose, and we are using for calculating the parity, we are using this XOR operation, right? So can you tell the truth table of this operation? So 0, 0, that is 1, right? 1, 0, 0,
0.
I think this is the opposite one. 0,
Yes,
0,
sir.
0,
It's
and
other
1,
way
0
around.
is. Yeah.
0, 1 is 1, 1, 0
Yeah,
is
yeah.
1, and 1, 1 is 0.
Yeah. Okay. So can you tell
Sir,
what is
how is XOR operation working? Can you?
XOR operation? XOR operation is the when there is the same digit, means same value, then we apply the this 0, 1, and when opposite bit is there, then set bit is 1, right? So here you can say there is the opposite bit.
So opposite means true, and
yeah. Opposite
same
means
false.
true, as same means false.
Okay.
So we do the XOR operation on 3, right? So we can first performs, then this is also possible here. This is also associative also, the XOR operations. So first we do here. It is the. So you tell me what is the XOR of output of this one? 1, 1,
0,
0, 0, 1, 1, and 1, 1,
0, 0.
0. And after that we perform this one, right? So that is 0, 0, 0,
0,
and
0,
0, and 1. So
1.
this is the parity bit is 1, 0, 0, right?
Yeah.
Suppose there is the 1, so error occur here, right? This one means this bit is set to 0. Maybe a failure occurrence. So how to calculate to find this one is, so you detect this one is crashed, this got crashed, right? So or failure occur. How to find? If you perform the XOR operation of these three, then you get this one, right? So let's check. That is some 101 110. So what is the value of that? 10 1 1 0 1 1 and the 0, right? And this one is the XOR operation is 1 1
1
1
1
and the 1 and the
and
1. And you can see this is the original bit.
Yeah.
Right. This is how we means finds the what is the original bit is here. So parity bit is a use for the error detection also, and we can also use for the recovery purpose. So
Okay.
I hope it is clear to you. The question is also given like this. There is the 5 disk is there. The 4 disk is we store the original information, and the 5th bit is a use for the parity bit, right? And so 1 disk is means 1 disk got failed, right? So data got corrupted. You have to find the data of that, and after that you have to find what is the original data of that, right?
Yeah.
Yeah. So you can make the similar question, this one. So the question is that what is the original? So this is the 4 disk is there, and 3 disk is the use for the data bit, and 1 is the use for the parity bit, right? So what was the original value of this one? So that is 7, right? Just for example. And this one is a 5, and this one is a 6, right? So this is the question, what is the original value of the disk 2? So I hope it is clear to you.
Sir, could you explain once again how do we calculate the original value?
Yeah. So there is the 4 disk, right?
Yes,
Disk
sir.
1, disk 2, and disk 3, and the disk 4. So these 3 disk 1, 2, 3. These 3 disks are used for store the data bits, right?
Yes, sir.
Yeah. These 3 are used for the data bit, and this one is the use for the parity bits. So how we calculate? First we discussed how we calculate the parity bits, right? So this is the original bit, right?
Yes, sir.
So if we perform we take the XOR operation, right? And this is the XOR truth table, right? So if same
Yes,
table,
sir.
same bit are there, then 0, and if different bit are there, then we set to 1, right? I hope
Yes, sir.
yeah. So after we perform the XOR operation, we get this one. So if we perform the XOR operation of these 3 bits, so we get the parity bit as this one, right? So if any disk failure, suppose the disk 2 got failed, right? So you have to find the what was the original value of that disk 2, right? So how to find that? You perform the XOR operation of 1, 3, and the parity bit. So we did same here. So this is the 101. So 101 and the 110, and perform the XOR operation, and then we gets the final output of the disk.
Okay, so sir, this is used in case one disk fails, right? We calculate the XOR of the other 3 disks to find the original value of the disk that failed.
Yeah.
Got it, sir.
Okay.
Sir, is there any advantage using many parity disk?
Yeah, we can recover the single disk in the single parity bit.
And for two parity bit, we can recover two disks.
Yeah, 2 disk.
Okay.
So, sir, how we basically decide the number of parity disks we want to employ? for this purpose. Like in RAID 2, they are using 4 disk for data and 3 parity disk.
I think there is a in slide there is one formula is there how many beats are required in
No,
slide.
I'm asking like, is there any connection between like that if we are taking, let's say 10 disk for data storage, so we have to take at least this much number of parity disk?
For now, I can say only one recover only one disk failure. So here you can check. Hello.
Yes,
Hello.
sir. I think
Yeah.
your connection was lost in between.
Yeah, your voice was not audible to us.
Yeah. So for now, I can say there is the only single bit parity can detect only one disk failure. So it does not depend upon the how many disks are present.
Okay, so it is based on the requirement we have, kind of
yeah.
application we want to.
Yeah.
So in RAID 2, like we are using 4 disks for data storage, so 3 parity we are taking, right?
If we want to calculate the 4 disk failure, right?
Yeah.
Yeah.
Sir, I have a doubt related to intern.
In same topic.
No, sir, it's related to the end term, general doubt. The exam.
Sir, just one doubt on this parity part. How do we, is the approach different when it's odd parity and even parity?
I think odd parity means just confirm it's just there is one.
Okay, even I'm not very sure, but that was like mentioned in the lecture.
Yeah, suppose there is this 4 bit is there. Okay, in the odd parity bit you have to make this one is just confirm which one is the odd bit and which one is the even bit. I'm just telling. Okay, in the odd bit, I think this one is correct. In the odd parity bits, you have to make this one is the parity bit, right? So these are the data bits and this one is the parity bits. You have to make this, the set bit is the odd, means make it odd.
Correct.
So here you can say there is the 2 bit, so you have to make the 3 bit.
Yeah.
So this is how. And for the even bit, you have to make this one as the even bit.
Yeah.
And that is the 1. And that already it is the even numbers of bit.
Right.
So you have
So it'll be 0.
Yeah.
Okay. So the XOR approach, will it change if it is odd or even parity?
No, this is the general approach.
Okay. So that will not matter.
No.
Okay. Thank you.
Odd or even parity, that is different approach. XOR is different approach, right, sir?
Yeah.
Oh, so okay, same thing. Okay, so we can use the odd or even parity approach also here.
Yeah. Suppose this one is the even parity bits. Yeah. So here, this after the crash happened or the any failure occur. So this is the even parity bits, and you got this one, right?
Yeah.
This one is used for the error detection, right? So you can check here. 1, 2, 3.
Yeah.
Hence the even parity bits, this is the 0. That means here error happened, right?
Yeah.
Error is there, but you cannot detect which one is
Which
the error.
disk? Okay.
Yeah.
But using the XOR approach, we can detect that.
Yeah, you can detect.
Okay, okay, understood.
The odd parity and even parity. This is, I think, mainly used in case of communication.
Yeah, and the error detection also. This is.
Yes, sir. I mean, in communication, I think what I read, it was way back, but I remember that in communication, we use this odd and even parity to check if the data is correct or not. We don't recover the data or detect where the data gone wrong, but we check that if the data is correct or not.
Yeah.
Okay, thank
so
you.
this is for this one is simple for the error detection, and here you can also use for the error detection and the error recovery also.
Okay.
This one is useful.
Okay.
Someone is asking some general doubt in terms.
Oh, yes, sir, it's clear. Thank you, sir.
Thank you.
I find the answer in the discourse.
Okay.
Can you explain what is B plus tree concurrency control algorithm?
I see. B plus tree concurrency algorithm is advanced concept. So these are it's not required. So if you are interested, you can read the course book.
Okay, like professor has used.
Yes. Yes. These are not required. So if you are really interested, you can you can read the book course.
Okay.
Sir, hello, sir.
Yes.
Sir, in rate 5, that is distributed parity, it is saying that we can do several write requests because the bottleneck of using single check disk is eliminated. So in this RAID system, we can do 2 writes simultaneously. Like for one is for the A1, A2, A3, and the other is for B1, B2, B3. I am trying to write the A bit and B bit. I can do that simultaneously. Hello, sir.
Hello. Yeah. So here point is in the RAID 5. Let me share. Is it visible to you? Right.
Yes.
One thing I need to show you here. Here you can see in the RAID 4, we can see only the parity bit is present on only one disk. That is the disk 3.
Yes, sir.
So every time you write this one, any data value, you have to change the parity bit also.
Yes, sir.
So there is the kind of means you provides the load in the disk 3.
Yes.
And that is for the every write, right? And you using the disk 3. So in the RAID 5, it distribute this parity bits in here, this parity bits here, and this one. So the point is we distribute this parity bits in all this 4 block, right?
Yes, sir.
Yeah. So yeah.
Sir, one thing, sir. So if I am trying to write any value in B, okay, so I can do it in I can write either B1 or B2 or B3, or I have to access all of them to write them. Like I want to change only the value of B2. I can do that. I can take that single disk. I can access that single disk, and can I just write it, or I have to access the whole row?
No. If you want to write on this one, so
Yes, sir.
you have to also need to update this one.
Okay. So then I
Parity
have,
bits all the times you have to needs to update the parity bits if you have any.
yes, sir. Parity bit that I understood, but I am saying that I have other than the parity bit, I don't have to update any other. That is B1 and B3. I don't have to update those blocks.
No.
Okay. So that's how we are eliminating that bottleneck. Okay, sir.
Yeah, it's the bottlenecks one. This one bottlenecks. So
Yes.
this is a kind of overload on this particular disk.
Yes, sir. So if I am trying to write on A2 and B3, then in case of RAID 5, I can do that simultaneously because I am accessing two other disks. But in case of RAID 1, RAID 4, I cannot do that.
Yeah.
Yes, understood. Sir, this time the questions are going to be hard or the same level, sir?
So this kind question is up to you. Yeah, how much you have read that concept.
No, that is okay. So, but like the question difficulty level of the end term, will it be same as the previous quiz 1 and quiz 2?
Piyush sir, would you like to comment?
Yes, Abhishek. What was your question?
Yes, sir. So the difficulty level of end term, will it be the same as quiz 1 and quiz 2?
Yes, same difficulty level of quiz 1 and quiz 2.
So in quiz 2, paper was somewhat theoretical. Will it be like this only? This type of question paper will be there in the end term?
No, there will combination of both theory question also and numerical type also, like problem also. Yeah.
Okay.
And one thing, sir, regarding the portal of practical exam, sir, it is a humble request to improve the portal, not only the working of it, but also like let us see some output also, like for the question number 8. The problem that I faced is like I was getting error, but I cannot find where the error was happening. I was getting like incomplete, no, incorrect error, incorrect code, and yes, I was getting incorrect codes continuously. So, but I was not able to detect where I am doing the error. So if you can improve the portal, I think that then it will be much easier, not easier, but much better for the upcoming batches.
Yes, we have noted down your feedback from this course, so we are working on that.
Okay.
Sir, one doubt from quiz 2, there was something called sequential clustering which was referred. Is that the same as sequential indexing?
Sequential indexing was there. Clustering.
The word you was used was sequential clustering. That's why actually I got confused even in the quiz. Multi-table clustering was there, which is the same as what was used in the lecture.
Sequential clustering. That is same as sequential like organization schema.
Okay, thanks.
So can you also discuss the concept of deadlock, especially like the last question of week 10 graded assignment?
Okay. Shubhendu, do you have that question?
Okay, so let me check. Yeah, okay. Let me share my screen. Oh, is this question right? Hello?
Yes, yes.
Okay, so in a schedule S, there are three transactions, namely T1, T2, T3. Each of these transactions will write to a file secondary storage hard disk. For writing, they need access to a system component C, which is total of X instances. So total of X instances. If T1 require 3 instances, so if T1 require 3 instances, sorry, T1 require 3 instances. T2 require 5 instances. So T2 require 5 instances. T3 require 3 instances. T3 require 3 instances. Okay, then C to complete the transaction. Then what should be the minimum value of X so that no deadlock will occur when two-phase locking protocol is used in the system. So basically, so what is the minimum value of X so that means no deadlock will occur. So everyone means you got the question right? Hello?
Yeah.
Okay. So suppose when deadlock will occur, suppose T1 hold 2 instances, suppose T1 hold 2 instances, T2 hold 4 instances, and T3 hold 2 instances. Suppose 2, 4, 6. Suppose there are 8 instances, and everyone hold n-1 instances. So then deadlock will occur, right? No one complete the transaction.
Okay. Understand. Okay.
Yeah. Suppose there are one more instances. So suppose there are one instances. So anyone can occupy the instances. Suppose T1 occupy, then T1 require 3 instances. So T1 will complete the instances and release the instances. So then there will be, suppose T1 completed, then 3 instances will be released. Then T2 will require 5 instances. Then T2 can complete. Then T3 can complete. So 9 instances is required minimum.
Okay. So the formula is suppose there are 3 such things.
Okay. Suppose
one of each plus 1.
Yeah. So suppose T1 has required A instances, T1 require B instances, T2 require C sequences. Then minimum numbers of instances require that no deadlock will occur. Then A-1 plus B-1 plus C-1 plus 1. Yeah.
This is regardless of the number. So even if I give 5 such transactions, still the same.
So see, this formula may not, means
no, if I have A, B, C, D, E,
it sometimes may not work because you have to see how many instances is required. Suppose let me give one example so that you can, so this formula may not work sometimes. Suppose, okay, let me write it is, suppose T2 requires suppose 7 instances and T3 requires suppose 8 instances. So this formula may not work because see.
Sir, can you first define what instances is here over here?
Instances means suppose some post some processes, means suppose means means instances means
You can take is as the sum. There is suppose there is one resource, and so for that resource you need some instance of that.
yeah.
Is it?
We think about it as a part of that resource.
Yeah.
Because when I read this question, I went for option number 4 because I thought that you cannot access a part of a resource. Like if you are accessing variable C, you have to access it in the whole. So now in the locking mechanism, we learned that whenever there is whenever some transaction is accessing a variable, until and unless it release the lock of that variable, you will not be able another transaction will not be able to access that variable.
So say when suppose after the completion of T1, T3 means T1 instances will be free, right?
Yes, so we can also
we can use it means T2 for the T2 instances.
Okay. So we can
So,
access instances of a variable and
yeah.
that's and release lock and lock.
Yes. Yes. So you got it, everyone? Hello.
So sir, if this question comes, we will use this formula only.
Yeah. This formula will work maximum cases.
So the A-1 plus B-1 formula.
You have to see means how many instances is required. So suppose sometimes may not works in A-1 B-1 this formula. So if there is a question, so this formula will works. Suppose there are question, so A-1 plus B-1 plus C-1 plus 1 instances. It depends on questions.
Sir, one more thing. So what was the need for two-phase locking over here? Like all these transactions are independent, right? It's a serial transaction.
Yeah, so it is basically means suppose means just right, not anything. It depends on the questions.
Sir, so sir, for this question, like you said, like this formula may not work in every case. So
Yes.
So sir, what should be our concept? Like what concept should we use while calculating this?
So basically, you have to see minimum instances means I have calculated, right? Suppose when that first we have to see when deadlock will occur. So suppose okay, so let me remove it is so
You can increase the eraser size, sir.
okay.
Sir, you can use the select tool. In one go, you can delete.
Okay. So when deadlock, hello, am I audible? Hello.
Yes, sir. Yes, sir.
So first we have to see. Pradeep, can you meet? First we have to see when deadlock will occur. So T1 has 3 instances. T2 has 5 instances, and T3 has 3 instances. So once everyone's suppose occupy one less instances, suppose 2 instances, suppose 4 instances, and there is 2 instances. So there will be worst case, right? So
Yes.
everyone's, so then deadlock will occur.
Yes, sir.
So then if you increase one more instances, then means anyone means
avoid,
yes, anyone transaction complete, and that will free the instances. So suppose this is T1, suppose this is T2, then suppose this is T3. Suppose this is completed, 3 instances will be free, right?
Yes, sir.
And you have to see these 3 instances, is anyone transaction can complete with the help of these 3 instances. If yes, then complete the transaction. So this transaction will complete. Then 5 plus
Yeah, I
5.
understand. So there are cases where this may not work, but most of the time I think it should work.
Yeah, most of the things it will work. So you have to see, depends on the question.
I understand, sir. So let's say it can also be a case like T1, T2, and T3. All of them are accessing all the instances. Like they are accessing 5 and 3. So in that case, 9 will cause a dead block. 9 instance will cause a dead block. So it is better we have 12 instances.
Yes. Yeah, you have to see, depends on the questions.
So here, I mean here, is it if 3 instances, 5 instances, see to complete the then what?
Sir, if I go one by one, if I go just T1, I'll give all the instances there, 3, and then release it and use the 3 elements in T2. If I go
yes,
process.
yeah, this will be the best case, right?
So that will be like serial, right? T1.
Yeah. So suppose I got your question. Yeah, but this will be best case, but may possible everyone occupy the means one less instance. So that will be deadlock, right? Hello.
So, sir, it'll depend on how the schedule is defined, right? Whether it is serial or concurrent or
yes.
yeah. Okay. So in these kind of questions, then should we calculate for worst case? That is, all of them are running concurrently. Can we take it that way?
Yes.
Okay.
Sir, is there any reason you are taking one less instance for every transaction in this question? I mean, because you can go for all the transactions like 353, you can go for that, but instead you are
yes. Suppose one student previous says, suppose there are 5 instances, you can complete T1. You can then, after the completion of T2, you can complete also T2. After the completion of T3, T2, you can complete T3. Yes, you can complete, but there are some may possible that everyone occupies means max mean how means.
No, sir, I understand that, but what I am trying to say is you are checking for a condition where each of them are taking one instance less from
Yes.
From whatever instance they require. So
yes.
my question is like, is there any particular reason or is there anything that is mentioned in the question for that you are taking this one instance less? Because I think if we are preparing for the worst case scenario, then we should think about 353. Like all of them are accessing all the instances.
Yes. Suppose all of suppose say suppose 353. So we can complete means there are 3 5
11, sir. That means
11. Yeah. So then deadlock will not occur, right?
I mean, if 11.
So we have asked the minimum value of X so that deadlock will not occur. So there are 10 instances, then deadlock will not occur. So we have to find minimum value of X, that how many instances that deadlock will not occur.
Sir, yes, sir. That is what I am saying. Like you are taking the number of instances, the minimum number of instances depending on the worst case scenario.
Yes.
Yes. So, like some previous student who said that there can be a scenario for 5 also, like 5 instances are there. Then we have to do is T1, T2, T3. We cannot do them simultaneously. We have to do one after another.
Okay, so let's give one example. So suppose T1 has 3 instances. So if you are concurrently, so T1 requires 3 instances. Suppose this occupy 1 instance. After that, T1, T2 occupy 1 instance. After that, T3, and this will we can occupy the instances, right? Hello.
Yes. Yes.
So suppose this is 2 instances, then T2 suppose once 1 2. So let's write 2. That will be better. T2 1 2 3 4. After that, suppose this is like that. So in that case, the deadlock would occur. So because instances is not available. So if anyone get 1 instances, then this transaction also at 1 instance. This transaction also at 1 instances. This transaction also at 1 instance. If anyone get 1 instance, then complete the instances, right? After the complete the instances will be free. Then other transaction can use.
Yes, sir.
So
that I understood, sir. But as we are preparing for the worst case scenario.
Yes. So we've also asked the minimum value of X. So
we have to give the minimum value of AX for the worst case scenario.
For deadlock will not occur.
Yes, I mean deadlock will not occur, and we have to consider the worst case scenario because if we are not taking the worst case, then we can go for option number A, that is 5 also.
Yes. So if option number A, suppose there are 5. So suppose 5 instances, means deadlock may possible, right?
Yes, deadlock may be possible when we are when all the 3 transactions are operating simultaneously.
Yeah. So suppose there is available 9 instances. Can you say one scenario that
Deadlock can occur in this case also.
in 9 scenario?
Yes.
Okay, can you tell how occur?
So sir, T1, T3 and T1, T2 and T3. T1 is yes, sir.
Yeah.
T1 is taking 3 instances.
T1 taking 3 instances. So if T1 taking 3 instances, then it will complete the transaction, right?
Oh, okay. I understood. Okay, sir.
Okay. So you got it now because.
Yes. Now I got it, sir.
Okay. Okay, so everyone clear this question?
Is that clear?
Okay.
This is a nice.
So where is this question from?
I think graded question.
Okay, sir.
Okay. Any other question?
Hello. Yeah. Any other question from week 1 to 12?
Sir, I had a doubt regarding RAID levels. So RAID 3 is striping plus parity. So can it be considered as a hybrid RAID level?
What is your point on the?
Sir, I'm asking if RAID 3 is also a hybrid level like RAID 1.0 and all.
Hybrid level?
Yeah, they introduce hybrid RAID levels, right? Like RAID 10 and 50 and all.
Yeah. That's a combination of the
Yes,
two
sir.
or
Yes, sir. But if we
that's
look at
why.
it, RAID 3 is striping plus parity. Striping is RAID 0, parity is RAID 2. So isn't RAID 3 RAID 2 plus RAID 0?
No. That is only one feature you can say. One
So, okay,
property.
there is more to it.
Yeah.
That is not covered. Okay, got it, sir.
Also, RAID 2 is bit striping, RAID 3 is byte striping.
Yeah. Hello, Bhavya.
Yes, sir, got it.
Yeah.
Okay, any doubt? So we have just released the revision, sorry, not revision, summary video from week 1 to 12 and slides also. You can check the portal. Same thing we have released for the last time also. I'm audible, right?
Yes, sir, you are audible.
Yes, sir.
Yes, sir.
So where have these been uploaded?
The portal only you can see the summary section on the left side.
Okay, sir.
Video is also there and the slides were uploaded in the folder under lecture/PPT slide. Okay, so any other doubt from week 1 to 12? Week 1 have some mostly theoretical concepts, and for that you can refer to the week 1 revision slides. And week 2 and 3 is mostly based on SQL. So I think the session that we have to practice session, that will be enough. Then from week 4 is ER diagram and TRC and DRC part. You can refer to the lecture or watch the tutorial on that also, right?
Sir, for numericals, if we know how to solve the assignment questions, that's sufficient, right?
Yes.
Okay.
If you have gone through practice and graded assignment question,
Yeah.
that will be sufficient. Yeah.
Okay.
Gone through means you have solved it by your own, not just looking at the solution.
Yeah.
Okay, so there are few questions based on last income. Let me share just 1 minute. So we'll go through the question. So by this we can revise the concept also. So this question is based on TRC, Tupper relation calculus. TRC. So this is the relation given, and you have to find out the equivalent statement, like equivalent TRC query for that. So the final names of students who have issued a book, author name SK Sharma. Okay, so here you can see these two are correct. But can you tell me why these two options are not correct? My screen is visible, right?
You can see it's we have to look at that thing.
Yeah, we're just going.
It is not easy to figure out the difference. Even the difference I can't figure out actually.
Just maybe 1 minute or 30 seconds will take, and then.
Where in option C the there exists symbol, that is an issue.
Yeah. Because we have used here like s.id, b.id, but we have not specified like what is b and what is s here. So for that we have to use there exists s, there exists I, there exists b, right? So that's why this option is not correct. And why the fourth option?
B.
Here you can say we have mentioned x, I, and okay. So then we have mentioned the condition, that is I dot SID equals to S dot SID, means we are joining these two tables, right? And here also there exists B belong to book, and here also I mentioned the condition. Means you are joining these two tables.
The condition is missing in the last option. So that will be
because you are not joining this table, right? So basically, give us the cross product between these two join resultant table and this one. So we will not get the required result. That is the names of a student, right? So that's why this option is also incorrect.
The second and third, I don't think I would have figured out the difference actually. It's a very minor difference.
Both the options are correct. Like there are different ways we can represent the ARC query. So here we have specified like this book relation, because we have joined these three tables, then we have performed the condition. And here we have joined these two tables, then we perform one condition, and then we have specified this table. Like, join these two tables. Okay.
Sir, when we are joining, so we need to use the there exist clause.
Yeah.
Yeah. Okay.
Because we are using this attribute, right? SID variable S. So what is S? We have to define that, right? So there exists S belong to student. So S belong to student table. That's it.
Yeah, got it. Thank you.
Yes, this question. Okay, same relations are given. Based on that, we have to find the name of student who issued a book, ID this. So here, first thing, like we can perform the cross product because we have to find out the book issued. So with the book issued and the students table, right? Because we have to find out the name of students. But can you tell me why option first is correct? Because option D is anyway correct. We are joining these two tables and applying the condition, right? But why option 1 is correct?
Sir, it is like query optimization what we studied. We are first sorting the book issue and then doing the natural join.
Yeah, so just what we have discussed earlier. So this is E2, right? So this theta 1 belongs to E1. So that's why we can apply theta 1 to this particular table. Then we can perform the cross product, right? Yeah, so any doubt in this question, in these two questions, based on relational algebra, TRC and ARC part? Okay.
Good question.
Yeah, thank you. Then this is question. Okay, so here we have to find out the attributes in the books table, order table. Okay, first tell me how many relations are required here? Books, orders, customer, or only books and orders, or only books and customers?
Only books and customer. Books, customer.
We
Order
need
also
three,
requires
right? Books, order, customer. Yeah.
Books, order, customer.
So what are the attribute of books relation?
ISBN.
Yeah, ISBN, author, price,
price
cost.
and stuff.
And for customers, customer
Customer
ID,
ID,
customer
name, pin code.
And for orders,
Customer ID.
yes.
ISBN, quantity,
order date.
Yeah. So why we are using this customer ID and ISBN here in orders table?
Because they are the keys into the foreign keys into the.
These are the foreign keys, right?
Yeah.
So here it is many to many relation. If it is an arrow, it means many to one, and here if it's an arrow, then it is 1 to 1. Okay, I think we have specified this. Okay, so if you refer to the quiz 1 revision slide, we have given one table in that. Okay, you can refer to that. Then okay, so next question. Okay, so this is from week 5 and week 6 concept. Okay, so for checking anything like for normalization or decomposition, we first need to calculate the candidate key, right? So how to find out the candidate key here? Yes,
Attribute closure.
Yes, sir.
And what is the candidate key here? How we can determine?
First, we check the right-hand side dependencies if they are present.
Yeah, so here B is present, E is present, G is present, H is present, E and G is present, right? So A, C, D, F is not present on any right hand side of any functional dependency. Now let us take the closure of that. Now if we got all the attributes, if we get all the attributes by taking the closure of ACDF, then we can say that it is a candidate key. Okay. Now let us take the closure of ACDF. ACDF will itself include ACDF, and from A we can get B. From ACDF only we can get EG. What is remaining? A, B, C, D, E, F, G, H, H. So H is remaining. From E and F we can get H, right? So by this we get all the attributes present in the relation R. So ACDF is the candidate key. Now what are the prime attribute here?
A, C, D, and F.
Yes. A, comma, C, comma, D, comma, F are the prime attribute. Now we have to see whether this R1, R2, and R3 is in which higher normal form. Higher normal form of all the three relations. How to see? Let us take R1 first. What are the applicable functional dependencies to this relation?
A determines B.
A determines B.
Yeah, only A determines B. So is this in which higher normal form? 3NF, BCNF, 2NF?
BCNF.
Yeah, because the condition for BCNF is left hand side of any functional dependency must be a super key, right?
Yeah.
Yes, sir.
So here A is a super key. So this is in BCNF. Now what about R2?
The dependencies are ACDF. No, that will not be there.
We can split it, right? ACDF.
Yeah, determines E. Correct.
And determine G, right?
Yeah, so ACDF determines E will be there here. Again, BCNF.
But if you observe, this is the real functional dependency, okay? Now R3, EF, GH.
EF determines G.
EF determines G, and EF determines
EF determines H. Yes.
So this is also applicable. Yeah, so this is also in this unit. Okay. Now
Yes,
let us check for the whether this R1, R2, R3 is a lossless decomposition or not. How to check that?
You have to take the union first.
And see if intersection determines any of the two.
Yeah. So let us take a union of R1 and R2 here. But first we have to see whether R1 union R2 union R3 is giving the all the attributes in the relation R or not.
That is satisfied.
So it is satisfied. So R1. Okay. So then next is R1 intersection R2. The common attribute is A. Now, if we take the closure of A, are we getting R1 or R2? That we have to see.
Yes,
so
we
from
are.
this functional dependency, we are getting
R1.
AB, that is R1, right? So now say R12 equals to R1 union R2, which is AB. A, B, C, D, E, F. Now we have to check R12 intersection R3. So the common attributes are
EF.
F. Yeah. Now if I take the closure of EF, are we getting R12 or R3?
We're getting R3.
Yeah.
So from this we can say we are getting R3, right? So this decomposition is lossless decomposition. Okay, so I hope you understand how to calculate candidate key, how to check the lossless decomposition is there or not. Okay. Now here, this is the important question. Okay, so I will not solve this. If anyone wants to volunteer, like how to go about this question. So we have to decompose this relation R into small relation, each of which is in BCNF. Okay. We have to find out the minimum number of relations. So how to go about this? Yes, anyone? What is the first step?
We have to decompose each functional dependency as a relation. Like if I determines JK, IJK will be one relation.
So this is 1, 2, 3, 4. But we
Yeah.
want minimum number of relations.
Yeah, so after that, we need to see if any of them is a subset of the other.
So we can just calculate the canonical cover and sort them that way.
Yes, that thing is also we can do, but
Sir, we can find the candidate key and
that is our conventional approach. We have to find the candidate key, then see it's satisfying our BCNF condition or not. Then we have to decompose that relation.
yes, sir.
Okay. What is the candidate key here?
I.
IJ. IJ is there, M is also there, L is also there, I is there. So all the attributes are present on the right hand side of functional dependency. So in that case, you have to take the closure of individual attribute here. Now let us take the closure of I. So are we getting all the attributes? From I will get I, J, K, from J, L, from K, L, M. So this is equal to R. Now let us take the closure of J, JL only.
JL.
Yeah. So can we get further? No, right?
KL to M.
Yes, sorry. K is not there. No?
Yeah.
So now take the closure of K. Only K. Right?
K determines only K, sir.
Yeah. Now L determines only L, right? Yes.
And M determines I.
M, so
I
if you take the closure
determines
of M, then it
M
will be
determines I,
and
and
from
I
I we
determines
get
everything.
all the relation.
I.
Right? Because I is there and I is already a candidate key, so we can set from M we can get I, and from I we can get all the relation R, right?
So M is the candidate. Yeah.
Yes, I and M is the candidate key, but we need to check for these three also, the combination of these three elements. So combination are JK, KL, and JL, right? Now let us take the closure of JK.
JK.
JK. Then,
L will come, then M.
L, M.
J determines L, so
Yeah,
L
that's the
will come.
closure. That will give a canonical cover. Yeah,
Yeah.
that will give.
M.
L will come, then KL will get M, and from M we can get all the relation R, right?
Yeah.
So this is also a candidate key. Let us take the closure of KL.
KL,
M and
that's the
again.
candidate key.
Yeah, so this is also
Yeah.
candidate key because from M we are getting all the relation R. Now JL.
JL, nothing.
It'll only be JL, I think.
Nothing else.
Yeah, only JL.
So our candidate key are I, M, KL, and JK. Right, these are the 4 candidate keys. Now, if you observe, if you take the combination of any other attribute, it will give the relation R, but that will be the super key, right? We want only candidate key. So these 4 are the candidate key. This is JL. Okay, so once we know these are the candidate key, and the prime attributes are I, M, K, L, J. And what is the next step? Yes, anyone? What is the condition for BCNF?
Sir, the left hand side should be
Super key.
Super key.
Yes. So now let us check this thing. I determine JK. So whether I is a super key?
Yeah.
Yes.
Yes.
KL determine M. So KL is a super key. Yes, it is a candidate key, right?
Yes.
J determine S will not satisfy our condition, right?
You don't need that, yeah.
So now let us check for M determine I. M is also super key. This functional dependency is violating our BCNF condition. Means for that we need to decompose this relation. How to decompose this relation? Just simply we have to take the closure of left hand side of this functional dependency, that is J here. If you take the closure of J, what you will get? JL only, right?
JL only,
yeah.
So we can make this as one relation, that is R1. Okay. Now we are decomposing this relation, so we should have lossless decomposition property, right? So what are the conditions for that? R1 union R2 must be equals to R, and R1 intersection R2 should determine R1 or R2. Now, if this is our R1, then what will be our R2 to satisfy this first condition?
It should be the entire thing again.
I, J, K, M. L is not required. I, J, K, and M.
Except L, everything, sir.
J should also be there.
Why J will be there?
Because
Union
to satisfy the condition, R1 intersection
Foreign
R2
key, yeah.
Otherwise,
determines R1.
intersection would be 5.
Yeah.
If we take L here, then it will not give us this R1 or R2, right? It will not satisfy this condition.
Yeah.
So that's why we are using J here. So this is the R2. Now if you see, now JL is applicable to this R1, so it's satisfying on BCNF condition, and rest of the three are satisfying, right? So we can say that R1 and R2 are the decomposed relation of R such that each of is in BCNF. So the number of relation will be 2 only.
Sir, could you
Sir-
please explain where did we get R1 and R2 from? Like what process we took? I understood until finding the super keys for BCNF.
Okay. So once you know the super key, like first we need to find out the candidate key, right? And
Yes,
every
sir.
candidate key is a super key.
Yes, sir.
So after that, we need to check which functional dependency is violating our BCNF condition. So if you observe this, I determine JK. Left hand side of this functional dependency is super key, that is our I, right?
Yes, sir.
Is
So
satisfying?
it satisfies BCNF.
Yeah, here also satisfied BCNF because it's our super
Yes,
key.
sir.
Because this is not satisfying JL. Because left hand side is not a
Super key.
super key here. And M determine I is also satisfying. Right?
Yes, sir.
So if this functional dependence is not satisfying, then in that case, what we have to do? We have to take the closure of left hand side of this functional dependency. That is J closure. That is JL, right? And now make this as one relation R1. Yes, Bhavya.
Yes, sir. Got it. Got it, sir.
Now to satisfy this lossless decomposition property, we need to select R2 such that it should satisfy these two conditions. And
So
for that,
basically,
we should have
Everything except L.
So basically here, J cannot be the super key for the full relation, but we have to make J super key for at least one relation.
One relation.
So they have to start with JL.
Yeah. Okay.
So basically,
it, sir.
whichever is not a super key, it has to be a super key of the smaller relation. So did I get that right?
Sorry, can you please repeat?
See, if we determine that one of the left side violates a BCNF, which means it is not a super key of the larger relation. Each such LHS, we need to create relations so that in that relation, there is a super key.
Yes. In that relation, for R1, JL, so J is a super key here, right? Because applicable functional dependencies only J determine here. Right?
Yeah. Suppose we had one more such, we may need three relations.
Yeah. If you have one more functional dependency that is not satisfying, then again we need to take the closure of that left hand side of functional dependency. Is that okay?
Sir, is this the only approach, or is there any other approach for this question? For solving BCNF decompose the.
It is a conventional approach. From this, you can decompose into 2NF, 3NF, BCNF, everything. But if you want to directly decompose this relation into 3NF, then there is one algorithm based on canonical cover. You have to find out the canonical cover of this functional dependency, and then we have to make the relation, right?
Yes, sir.
But if you follow this, you can decompose this relation R into 2NF, 3NF, or BCNF. So one example I have taken in the live session. In that I have decomposed one relation.
Yes, sir. I found this easy more than the finding canonical cover and decomposing it.
So I have taken one example. In that I have discussed how to decompose this relation R into 2NF, 3NF, and then BCNF. So that link is also provided in the discourse, like important session in that post. Okay, you can check that.
Yes, sir. Okay, I will check.
So for 3NF, I think one of the approaches in the lecture was to decompose into each of these and then see which is the which are the overlapping sets. So will that like is this an easier approach?
That was for canonical cover 3NF. For 3NF,
First
we
we have
find
to-
canonical cover.
Okay. So we
First
first
we have to
find
out canonical cover, and then from that you can make one relation of that functional dependency.
okay.
So can we summarize this approach? So we basically checked that whether each field, right, the closure, whether it will be a candidate key, right? We found the single fields, then we found the combination also, which are the candidates. So we identified all the candidate keys, right? Then we checked whether the LHS is a super key. And from there, we started decomposition. Is that the summary of the approach?
Yes. But for better understanding, you can watch that example because I have explained near about for 45 minutes. In that, I have taken relation R and decomposed into 2NF, 3NF, BCNF, all the things.
Which session is this, sir? Which week?
On the discourse, I have posted one link, important session.
Okay, important sessions. Okay.
In that, there is one decomposition plus normalization. Topic is there. There we have discussed one example. So if you just watch that example, you can solve any problem based on normalization and decomposition. So that example is more suitable to decompose into 2NF, 3NF, and then BCNF. Okay, so here JL, IKM, what are the attribute? J. Yeah. So, okay, so now can we check whether this two relation are dependency preserving or not? How to check that? Yes, anyone? So for R1, what are the applicable functional dependency?
J determines L.
Determines L.
Yeah.
G determines L.
Correct. And for R2,
I determines JK.
M, J. So FD2 applicable to this. I determines JK.
M determines I.
L is not there, right?
Yeah. M
Yes,
determines
sir.
I.
JL is okay. We already specified. M determines I.
M determines I.
So this is preserved. This is also preserved. J determine L is also preserved here. So we need to check whether KL determine M is preserved or not. So how to do that? How to check for that?
We have to compute F plus.
Yeah. So let us take F1 here. So let us take the closure of J here. From J I can get JL. Okay, so J determine L. And if I take the closure of L, can I get anything here? No, right?
No.
So only functional dependence is applicable to J determine L. Now let us check for F2. From I can determine. If I take the closure of I can get I, J, K. You have to take the closure based on the parent functional dependency. Okay. So I, J, K, from J, K. Because I is a candidate key, so I will get all the attributes, right?
Yeah.
So I can say that if from closure of I, if I am getting all the attributes, is I determine K, I determine M, and I determine J also, like for this relation R2. Can I say that?
Yes, sir.
Yeah, it means I determine K, M, J. Same thing for M also, because M is also the candidate key. So from M, I will get I, K, J. Right? Now from K, what I will get if I take the closure of K?
Only K.
Only K, right? Now let us take a closure of J.
J determines
I will get L. From L,
L.
no, right? Only
But
J. Now take the combination of KJ. If I take the combination of Kj, so what I am getting?
L and M and
Kj.
everything else.
L and KL from
Kj.
M. Yeah.
From M,
So
everything else.
what are the applicable? Like Kj determine M and Kj determine I, right? Because from M I will get I, right? Is any doubt in this? Because this one is another one, this and this. So this 4 function dependency we are getting from this R2, that is F2. Now let us check F plus such that F1 union F2. So it will have this J determine L, one functional dependency, 2, 3, 4, 5. So we can also write it MI also. Now from this 5 functional dependency, can we determine this? Which one? KL determine M, right? This is not satisfying our dependency preserving condition. So by using this 5 functional dependency, can I get this KL determine M? If I take the closure of KL based on this F plus, just see this 5 functional dependency. Can I get M if I take the closure of KL here?
No, sir.
No.
No. So means this dependency is not preserved. This R1 and R2 are in BCNF, but dependency is not preserved, right? So till 3NF, we can have dependency preservation, but in BCNF, it may be preserved or may not preserve, right? Any doubt in this?
Sir, I have one doubt.
Yes.
Sir, in R2, how can we say I can determine M? Because I can determine M only because we have L in the main relation. So how can we get I determine M here?
Here we need to take the closure of each attribute and based on the functional dependency.
Okay.
Direct
So
functional dependency.
okay.
So from I, we can get all the attribute, right? So
Yes,
I can
sir.
say that I determine K, I determine M, and I determine J.
Sir, I have one question here. So if I exclude KL determines M, L does not come on the left-hand side of any of the other relations independently. So can I conclude that it is not possible to arrive at KL determines M, or is that like a risky approach?
You can say that, but still you need to follow this step, right?
Okay, okay.
So there is one more example, like we have discussed it earlier. So in that satisfying that condition.
Okay, okay. In the live session, is it?
Yeah, in the live session.
Okay, I'll check that out. Yeah, thanks.
Okay, so this week 5 and 6 are important week. Here we have discussed about how to find candidate key, how to find prime attribute, then decomposition into 2NF, 3NF, BCNF, and then dependency preserving, right? Then we have extraneous attribute plus canonical cover, right? And what else we have here? That is multi-value dependencies also here, right? So in all the live session, we have discussed one example based on each concept. You can refer to that. Okay, so these 5 and 6 are important week. Okay. Yeah. So that's I think we have discussed this. Okay.
Sir, BCNF, I had one doubt. So if a relation is in BCNF, it can't have multi-valued dependencies, right?
It can have multi-value dependencies.
In 4NF, you can't have multi-value.
In 4NF, there should be no multi-value dependency.
Okay, I was a little confused there only. So if a BCNF has multi-valued dependency, then the left-hand side no longer remains a super key, right? If it is in BCNF, that means every functional dependency left-hand side is a super key.
So I multi-determine say J.
Yeah. So then I is no longer a super key, right? Because it's multi-determining J.
No, because we are calculating key based on function dependency only. We are not taking considering this NVD.
Okay, okay. No, let me put there across differently. So suppose I have a relation which is only like there is no this first set is not there, only the second set where I multi-determines J. And I don't know, maybe a couple of other relations, then yeah, so then this can't be in BCNF anymore, right?
Because we don't have any function dependency, so in that case, super key will be all combination of all the attributes.
Correct. So in that case, then it will not be in BCNF.
Like if we don't have any function dependency, right?
Correct. Yeah. Like even in the first example where you discussed, like if I say I multi-determines J, no, sorry, in the next one only, like suppose we have the first set itself, then I multi-determines J is not possible, right? Because I can't determine J and multi-determine J. It has to be the second one only.
No. If I multi-determine J, then I determine J, right? But reverse is not true.
Yes. So I can have both, you're saying then. But I can't have both, right? Because reverse is not true.
Yeah, I determine JK means I multi-determine JK is not true. But here you can say I determine J.
Okay. I think I sort of got it. Okay. So only by that implication of I determines J, multi-determines J, only that way BCNF is possible. That's an implied thing. But if a multi-determined relation comes in, it won't be in BCNF anymore because it won't imply the first part.
We cannot directly see that.
Like if I have, let's say F, the first one as I determines J and other things, and I is a super key, then I know that it's in BCNF.
Right.
If I have only the second one, then it is definitely not in BCNF because I know it multi-determines J. Okay, but you're saying it may or may not determine J. Okay.
Because in that case, all the attributes, this combination, all the attributes will be super key, right? So yeah, we need to check.
Okay, fine. Understood. So, okay, fine. Thanks.
Okay, so let's discuss. Okay, so suppose in this example, our system failed at transaction T6. So what are the, what we have to do, like undo or redo operation in T1, T2, or simply we can ignore that operation? Yes, anyone?
T1 can be ignored.
T1 can be ignored. Is the transaction that has committed before the last checkpoint that we can ignore?
T1, T2, T3 can be ignored. T4 has to be redone. T5, T6.
T5 also has to be redone.
T6 has to be undone.
Yes, sir.
From that, we can say that the transaction that has committed before the last checkpoint, recent checkpoint, that should be ignored, right? And that has committed before the system failure, that should be redone. And when the failure was happened and the transaction was going on, so that should be undone, right?
Yes.
Okay, that's it. Any other doubt from any other week? Week 4, 5, 6. Week 7, you can go to the revision slide of week 2. Sorry, week 2. Week 8, yeah. Week 9, 10 we discuss.
So the last question, it will be for all types of like deferred and immediate, both will be same or what?
This is timeline of transaction.
Okay.
We are not checking the log, right?
Okay, got it.
You can see the transaction T4 and T5 is committed, right? Before the system failure.
Yeah, I got it.
Okay, anyone any doubt? So in the Discourse, I have posted one post like important live session links. In that, I have mentioned few questions that is important. Okay, so like one question is based on decomposition plus normalization. Just go through that live session once. Okay. Okay, I think okay. If you have any question, you can ask, or otherwise we can wind up this session.
Thank you, sir. This is a very useful session.
Thank you.
Thank you. Thank you, everyone.
Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you all. Actually, particularly want to thank the course team. I didn't get a chance to attend many of the live sessions. I had to watch only the replays. But definitely the sessions have been very useful in getting the concepts. I think
thank
all
you so
the
much.
Thank you, sir.
all the difficult parts have been kind of explained well in the session. So that has been very, very useful. And particularly the tutorials also, like wherever needed, the tutorials have been very helpful. I want to thank the course team for putting together a good course. Thank you.
Yeah, so this
Thank
is
you,
our
sir.
last live session. So if you have any feedback on that, you can post it on the Discourse. Yeah, okay. Any positive, negative feedback, you can post it. No issue.
Thank you for feedback.
Okay.
For your
Thank
feedback.
you, everyone.